Okay, just a quick little dialogue about my hydraulic actuators, pistons note. Actuators are devices that use the force of the fluid power to perform some work. Most of the pistons we tend to think about are linear actuators, meaning they simply do the work by changing their length with the oil pushing against them. Styles, double acting. So a lot of our implements are used double acting because we want to not only just push it out, but be able to power it back on retraction as well. Simply means that we have a fluid outlet at each end. All right. We talked a little bit about this in lab, that the volume on the extend side of the piston is required to be a little bit more, because on the retraction side we have the volume of the piston rod, which takes up some room. So if we look at this, extending out is a little slower than retracting, but it is able to do more work because there is a greater surface area. We do not have the area of the rod to help us push back in, and though it might be not very big in proportion of the whole thing, it does make a little bit of a difference. So double acting piston is most common. It has provision at each end of the cylinder to allow the fluid to enter. Fluid is directed usually by means of a control valve. Pistons wouldn't work very well if every time you wanted to change direction you had to take a hose off and switch them to get the fluid to flow. Force available on the piston rod at the end of the piston will be less on the retraction than it is on extension due to the reduced working surface. Just talked about, and we talked about speed. The symbol is this, all right. And when this is your basic symbol, so this is the outside of your cylinder. We have wherever the oil goes in is my inputs, and then where the location of the rod is. So you can kind of figure it out from looking at the schematic what exactly it is. When we go from the double acting, right, to, and I guess I've got it off there now, to a single acting, all right, which is the same basic design. We have the outside of the cylinder, we have our piston working in here, but the thing with a single acting is we only are able to put the fluid in at one end. All right, the most common use of this would be like a hydraulic jack. In a single acting piston, all right, we say that we use an external or internal force to return the piston back to a home position. So in this we would use a valve and control the fluid going into here, and then we would use the external force. Now if it's a hydraulic jack, it's the weight of the vehicle, or it can be an external spring on it to retract the cylinder back in. But we only have one port. Excuse me, that was coming. All right, on a double rod end, all right, is the middle one here in the middle. And I'm going to put a graphic up at the end where it may be a little bit more, show you some other variations, but my note is only capturing the most common ones, all right? On a double rod end, we basically look like our double acting, but what we do is our piston rod extends out to each end. So whenever we add oil to one end, we have an extension on this side, a retraction on this side, and vice versa when we add oil here, and everything remains equal. Because the rod extends through each, the area on each side of the piston is going to be equal. So that means that the force that I'm going to be able to generate each way is going to be equal, and also the speed is going to be equal. The most common spot where you will see this is, just think of a power steering linkage in the middle, right? You wouldn't want more force to make a right turn than the left turn, or you wouldn't want a left turn to happen quicker than a right turn. So we need to keep them equal. All right. Telescopic cylinders are made with multiple sets of tubes or stages. We looked at one in the lab with just a two-stage. In most cases, when they extend, it is going to be the largest diameter of the piston that is going to extend first. Because the area is larger on that part of the piston, it should extend easier because it's capable of doing the most work. And as it reaches the end, then the oil pressure will build in on the second stage, and maybe we'll extend it. What we are doing is, as we extend it, is we're transferring the weight back so that as the piston gets up, we're able to perform the work easier. The other thing I would say about that is we need that because think about a dump truck. How long would a piston need to be if I had one single stage in order to get the dump box to go from sitting on the frame of the truck up to being able to dump a sticky load of clay out of the back? All right, just wouldn't be possible. The last one is a rotary piston. All right, a rotary piston is a little different, and we're going to look at a short video and the symbol. All right, symbol looks almost like an electrical plug-in symbol, line in, and a semicircle. In a rotary piston, it has absolutely nothing to do with changing the length. This is one of the variations. We simply, what happens is we have a set of almost like a worm gear on the inside, where it's a very coarse thread. When we apply fluid to one end or the other, we simply move this piston down. What this piston does is create rotary motion. All right, now unlike a hydraulic motor, it doesn't continue to rotate in one direction. It simply means it's capable of turning X amount of degrees and then back. All right, the plate does not move out, it simply rotates on its axis. All right, I'm going to put a little video up. One of the guys from the shop was able to get for me from his old place of work. All right, so I don't know how this will work out in looking at the video, but I will make sure that it is available either in class or online by itself. All right, so I'm going to kind of have to voice over all this. Now this is on the back of a garbage truck for lifting the green bins in. So you can see that as the oil flows in and out, it simply creates a rotary motion. There is no change in the length of it. And we're going to have a look down underneath. There are your two hydraulic lines feeding from one end to the other. All right. It's actually a fairly simple thing to operate or grasp. All right, that's it.